In the last few sessions, we've been looking at how to read and write from both text and binary files. In this one, we're going to dig inside the file and take a look at how the information is actually stored. So before we get started, let's do a quick recap of the difference between the two types of files. Let's start with the text file. So here we know that we've got printable characters in there. We also have readable characters, which means we can open that file and see what's in it using any text editor. It's portable because even if we're writing numeric values to that file using a format specifier, they're going to be written as characters that need to be then read back as from characters into the values. Good for small to medium amounts of data. Binary files are good for large amounts of data, and they can contain any kind of information, but that means that they're platform specific. So the size of integers varies from platform to platform, the different types of data available, and so on. So they are very system dependent, which is one of the biggest drawbacks of binary files. So let's take a look at programs that might be used to generate both a text file and a data file. So here we can see we have a file pointer, fptr. We have two file names, one for a text file and one for a data file. So we can see the only difference here is the extension. One has a txt extension, the other has a dat extension. And we have a string that we're going to write to both files. We have a hexadecimal value, 0a, that we're also going to write to those files. So let's look at our text file first. Here we have the open instruction for a text file. So we can see our mode is W. There's no B there, so that means we're going to be opening a text file. We check to make sure that the open was successful, and then we're going to use fprintf, which is a formatted print, to print an integer value, a space, and a string. So we're going to print the contents of number, which is the hex value 0a, followed by the string, this is what I wrote to the file. Because we're writing, it's very important that we close the file, and we're finished. Now we're going to take a look at writing a binary file. So we can use that same file pointer to write a binary file. We can see our mode is now write binary. We verify that it opened successfully, and here we're going to use fwrite to write information. First thing we do is we write number, and then we write the string. So we've written exactly the same information, close the file, which means those changes will be saved, and then we stop our program. Now what we're going to do is take a look inside that text file. So we can see here the code we used to generate that text file. We wrote it without a B here, so we know it's our text file, and we wrote two things, actually three things. We wrote an integer, we wrote a space, and we wrote a string. So our number was the hexadecimal value A, which converted to decimal is 10. And then we wrote a string that said, this is what I wrote to the file. So we have those three pieces of information that we should be able to find inside the file. So let's look at that file. So here we can see we're looking at file.txt, which is the one I created using this code. And here we have addresses down the left-hand side, and we have offsets from those addresses across the top. So if I look at this first byte, that's starting at address 0 in the file with an offset of 0. So that would be address 0, 1, 2, 3, and so on up to F. My second row here is going to start with address 10, 11, 12, up to 1F, and so on. So let's look at what's stored in that very first byte. We have a 31. Now in order to do this properly, you're going to need to have access to an ASCII table. So if you don't have one, pause this video and go and grab an ASCII table. And I want you to look up what 31 is on that ASCII table. And I think you should see that a 31 represents the digit 1. The next byte in our file is 30. And if you look up 30 on that ASCII table, what you'll see is it represents the character 0. So that those first 2 bytes represent that 1 0 or the integer value a. The next byte is 20. And if you look up 20 on your ASCII table, you'll find that that is the character for a space. Next one is a 54. So what's a 54? Well, 54 is a capital T, which happens to be the first character of the string, "This is what I wrote to the file." And if you follow that through each of these, you will find that what is stored in the file are all the characters that represent either numeric information, non-printable characters like spaces, or the actual characters that were in the string. Nice thing about using the tool we have here, which is an HXD hex editor that you can search for and download. It's free for you to use. You can see the ASCII equivalent of those bytes over here. So I can see the 1 0, the 1 0, there's my space, and there's the text that's written to the file. Now if we take a look at the results of the code that we used to write our binary file, we're going to use the same tool, the HXD hex editor, and we're going to look inside file.dat, which is the second file we created. Again, we can see our addresses down here and the offsets from those addresses here. So if we look at the first byte in our file, we see it's 0A. And 0A was that hexadecimal byte that we wrote. So in this file, we're actually seeing 4 bytes, 000010A, that are representing that integer value. So the platform I used had 4 bytes per integer. The next byte is 54, and if we look over there, we can see that capital T from my text. So we have THIS, space, there's our 20 for a space again, lowercase is, another space, then we have WHAT, and we can see that shown over here. Notice the first 4 now, whereas before we saw 1 0 and the space, now we're seeing dots. So if we see the dots over here, that means we have a non-printable character. So in our file, we had 0A, 000000, those representing our integer value. Well, that's not a printable character. All of the text we can see in this section, but our numbers are going to show up as actual values. Now let's take a look at the code that we could use to read these files. So here we can see the actual reading part. We start with our open, and here we're opening with the mode of R, which means we're going to read a text file. We check. We use fscanf to read. We used a formatted print. We used fprintf, so we're going to use a formatted read, fscanf. We're going to read an integer, a space, and a string. And we're going to store it in variables called number1 and string1. We close the file, just as a good practice, and then we can print the information that we read from the file. So we print number1, we print string1, and our actual output is shown here. So we can see a line that prints from the text file, prints number1 equals 10, and string equals this. Now why did my string say this instead of this is the text that I wrote to the file? And that's because we used fscanf. And fscanf only reads up to the first delimiter, which in this case was that space. So if we wanted to read it all, we would have to use something other than fscanf to get the rest of that string. So let's take a look at how we could do that. Over on the right hand side we have the code that we used to write the file. So we know that we wrote an integer, a space, and a string. So now if we look at a slight variation of our code, We're going to open our text file, we're going to verify it opened properly, and we're still going to use fscanf to get that integer value, and we're storing that in number 1. But now we can use fgetS in order to get the string. We know that fgetS will read past that first space and we'll get the whole string right up to the terminator instead of just the first word. So we're going to use fgetS to read the string. Remember, we have to say the size of the space we have reserved for it and the file pointer, and then we're going to close the file. Now if we look at our output and we print from the text file, we can see that down here has actually printed. We print our integer, and that's correct, and then we print our string, and there's our whole string. But notice right at the beginning here, we still have that space. So what would have been a good idea is maybe up here when we're reading the integer, that after the D we put a space so that it reads the integer and the space, and then when we get to the line where it reads the string, we wouldn't have this space. Now let's take a look at reading the data file. So we can see over here that we've got our write in binary. We check, we write the number, we write the string, and we close the file. Over here is the code that we could use to read that information. So here we're going to read in binary, so remember to put that B there. Now we're going to make sure we open properly, and we're going to read using fread. So we're going to read them in exactly the same order we wrote them. So we had an fwrite of number, we're going to fread number. We had an fwrite for string, we're going to fread that string. The trick that I use when I do this, if I copy this code from over here, I drop it in over here, and I change the fwrites to freads. If we do that, we know we're going to get exactly things in the order we wrote them back out. Then down here I can use those values, so I'm going to print from the binary file, here's my number, here's my string, and if we look down here we can see that we got our number of 10 and our full string.